On the 9th and 10th of April, we've got a Year 12 Graphs Internal, and the context is going to be GeoGebra art. But for merit and excellence, there'll be an element of moving art or generalisation. We're all going to teach Polly to make patterns using GeoGebra and possibly animations. So in order to get an idea of what that looks like, I'm going to show you a few files. This one here is just making a pattern with x squared and the square root functions. And this one is actually not what you're going to do, but it gives you an idea of the use of these graphs for art. I better speed up the crab. So you're looking at this picture, it's been coloured in paint and bits of the picture have been translated around, and if I click on that you'll see that there's graphs that are actually controlling the movement. Here's another example of controlling movement using a graph to create a picture. So if we take off the how, you can see it's looking okay there, and we can actually speed Jack in the Box up as well. This one isn't moving art as such, but you might like to try and fit a parabola to that action. This one's a clown. Unfortunately the file's been a little bit corrupted, but you get the general idea. That one's actually quite complicated to make. We're going to have a little bit of a look at how to make things jump like this in quite a natural motion. This is more like what your assessment will look like as to how to get that flying motion. Clearly you're changing your domain whilst the function's moving, and there's a transformation there, a vector translation, which we'll be doing as well. Here we are back to the idea of nice movement, nice controlled movement, which we'll be looking at a sine wave or cos wave to produce. Okay, this one has actually got nothing to do with it, it's just a little bit of fun, and all of these files are on the Google Drive for everyone to see and play with and see how it happens. Here we are back with random monkeys with slightly different movement patterns. So if you follow a particular monkey, can you work out which graph is actually creating that movement? Here I'm actually just going to make the functions visible so you get an idea of how those monkeys are moving. And this is the sort of pattern that you might get given. So we can even take away the grid and that. If you had that, could you turn it in to equations? So you would need to add an axis in a place that you want it to be, add the grid, and then here we've got a few hints if you like, and show equations. Now we don't have to do circles in this internal, so it's just the idea that we're looking at here. So before you panic, this is what's required for achieved: finding the graphs, domain and range of these three functions, and then drawing a parabola where that's the top of the hill and that's the base of the hill. So in order to draw that one, I want it going up and over, so I can see symmetry, that the two places that will cut the x-axis is going to be 11 and 17. So I've got some value times x minus 17 and x minus 11. So there I've got my parabola. Well, clearly I need to turn it up the other way, so it needs to be negative. And it needs to be a little bit more shallower than that, so I'll try 0.5. And a little bit more than 0.5. What about 0.6? Maybe 0.55. I'm doing a bit of guess and check here. I could have used algebra. So, and then for that hill, what was that one called? Function R. So I would actually have to have function R, and it would be between 11, the x value between 11 and 17. Now you're not doing it in GeoGebra in the internal, it just helps you practice your skills. So this one here, I can actually make a green hill and make it fat. There we go, close. So that's pretty much what's going to be expected. So you know what's expected. You've got heaps of resources. There's no excuses on this one. You've got into this course and you need to get Merit or Excellent.